Hi, Trigonometry. This is the video lesson for lesson 15, Solving Trigonometric Equations, Day 1. So we're going to open this lesson with a what's the difference. In the last lesson, you learned about inverse trigonometry and how it can be evaluated. And so the first example is an inverse trig expression. Or equation, I guess, since it does have an equal sign. And so let's talk about where sine is negative rad 3 over 2. Remember that inverse sine is only defined in quadrants 1 and quadrant 4. Since our expression is negative, that means that it must be in quadrant 4. Looking at quadrant 4, we know that sine is equal to negative rad 3 over 2 at 5 pi thirds. And so the answer to this expression is 5 pi thirds. Well, let's compare that with sine theta is equal to negative rad 3 over 2. This is not an inverse function, which means it's not on a restricted domain. That means our answer is every angle on the unit circle and beyond that equals negative rad 3 over 2. That leaves us with answers in both quadrant 3 and quadrant 4. So when we answer a question like this, if our domain is restricted, say 0 to 2 pi, then our answers would be 4 pi thirds for quadrant 3 and 5 pi thirds in quadrant 4. If our domain was not restricted, it just said all real numbers, then we would add a plus or minus 2 pi n to represent every possible revolution or coterminal angle that has an equivalent sign to the two we've answered. And so this is how trig equations connects to the previous lesson, inverse trig functions. If y equals sine x, then x equals inverse sine y, evaluated in each appropriate quadrant. So looking at the problem below, go ahead and type this expression. This is the same one from above. Type this expression in your calculator. And so we're just going to talk about that process from above and really break it down by steps. So the first thing we do is rewrite it to isolate the theta. We introduce an inverse trig function, and we use our calculator. If you type inverse sine of negative rad 3 over 2 in your calculator, make sure you're in degree mode so that you can interpret your solution. You're going to get negative 60 degrees. Put it on the unit circle. You get 300 degrees. Then you have to remember that there's an infinite number of solutions. Our first one is 300 degrees, but it can also be 240 and 300. And it can also be the format we wrote before, although I did use radians before. And now I'm writing my answer using degrees. So we've got three things we have to look out for. An inverse function is only going to have one solution in a limited quadrant. An inverse equation defined on the unit circle will have 1 to 4 answers, and an inverse equation for all values is going to have an infinite number of solutions represented by the plus or minus 360n. Let's take a look at another example. This one's going to mix in our traditional solving techniques. We know how to solve equations, and just add some trig to it. So over here, I've got 2 sine x minus 1, and my first step is going to be to add 1 to both sides of the equal sign. Now I'm left with the equivalent equation, 2 sine x equals 1. Divide by 2. Sine x equals 1/2. Since we're solving specifically on the unit circle, take a peek at your unit circle and look for where sine is equal to 1/2. In radians, since it's defined by pi, we should get pi 6th and 5 pi 6th. Next example. Because we have the minus 3, we're going to add 3 to both sides. 4 sine squared x equals 3. Divide both sides by 4. And then square root both sides of the equation. Now up top, we're going to get the square root of 3, which does not simplify, but keep in mind when you place a square root in the equation, you have to include positive and negative. For our denominator, the square root of 4 is 2. And so we're looking for all locations on the unit circle where sine is either positive rad 3 over 2 or negative rad 3 over 2. That's going to leave us with the solution pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Now it's interesting because there is a smarter way to write this. Since we're writing for all solutions, we've got to put a plus 2 pi n on the end of each answer. However, we know that pi thirds is 180 degrees or half a rotation or pi away from 4 pi thirds. So what we can really do is write pi thirds plus or minus n. So the same thing goes for 2 pi thirds, which is pi away from 5 pi thirds. And so we can also write our other answer as 2 pi thirds. Oh, that's supposed to say pi. Plus pi n. Let me correct this. Plus or minus pi n. All right, last example. This is actually going to say example 3 in your notes. Mine say 4, so just pretend like that's not there. I'm eliminating the previous example from your notes on this video because we're going to address quadratic equations in the next video notes. Here we've got a reciprocal function. And the first thing we want to do is to reciprocate. So we know that cotangent is the reciprocal of tangent. And so we're just going to reciprocate the other side as 1 over rad 3. Now I don't have my tangents memorized as well as I have my sines and cosines, so I'm going to let my calculator tell me what the inverse tangent of, this is a mess, inverse tangent of 1 over rad 3 is equal to. And so I get x equals 30 degrees. Well, tangent is not defined every 360 degrees, but it's actually defined every pi. So my answer is going to be 30 degrees plus or minus pi n, and this is not pi n. 30 degrees is a degree. Pi 6 plus or minus pi n. And by adding the pi n, this is actually going to encompass the answer in quadrant 3, where tangent is also 1 over rad 3. This concludes the video notes for lesson 15, Solving Trig Equations, part 1. Thank you for watching.